Um, so one of the things I'm trying to do in this class is do a transition, as it were. We learn a lot of interesting and important things doing academic computer science. But it's often very different than what you're going to hit when you go to work. And most of you probably, does anyone plan to become an academic computer scientist? They want to be a professor? Yeah, that's supposed to laugh that hard about the question, okay? But most people don't. I was a
answer the question. You asked me
Yeah, yes, yeah, but yes, that's very good. You did answer, and I like that. But I was a working software engineer for 20 years myself. So in the master's class, I had like 100 students, and I asked them who plans on being. So Carol and Ava Ziwe have shown up late. Oh, we have got plenty of chairs. All right. So there's huge differences, and I've talked to people out in industry who say that they feel there's a lot they have to teach people. And one of the things is, the fact that you're going to be expected to keep developing regularly. Also, the scope of projects is incredibly different. I was watching a C++ video. A guy from Google was talking about when they make changes, like they want to change a function name that's in a library they have. And he said, we may have the function may be called in tens of thousands of files. All right? So think about that. They're making a change, and they have to make the change across not tens of thousands of lines of code. I mean, your academic projects typically, you wind up writing 20, 50, 100 lines of code for something, right? They're not talking tens of thousands of lines of code. They're talking tens of thousands of files they're making the change across. The changes are so big that they can't make them in one swoop, he said, because it's not that, and Chani has arrived, it's not that Git won't let you check in 20,000 files at once. He said, but by the time there's many engineers working on these files, by the time the check-in went through, someone would have already been changing the file, and they'd have merge conflicts. So the check-in of 20,000 files will take so long that any number of them will have been changed during the period of the check-in. So they have to work in small batches where they hopefully can avoid that. And so they make the change in 100 files at a time or something. We have clients for some of our projects, outside clients, and this is important. We've got New York City as an outside client, and we have to look at what the client expectations are for when products will come and so forth. And we want to try to meet them to the extent we can. We also, what's the main difference? If you wanted to characterize the Ford mass assembly line production method versus the Toyota production method. And this, I've said, comes over into software development as the waterfall method versus agile, right? So what's the main difference? What is the central thing that Ford and Toyota did differently? Shani?
Instead of implementing things and once you're done, you move on to the next, it kind of cycles back and reevaluates things, and it's not one clear objective like you can alter and change.
Yeah, the Toyota method.
Toyota is
Yeah. So Ford was making huge batches of cars, right, and was counting on being able to sell them very cheaply. Toyota said, we're going to be flexible. We want to be able to pivot. So that's one thing we want to be able to do. People with agile development methods are able to do things like A/B testing. Um, you know how Amazon, when you buy something or when you're shopping, you go to check out, they say, here's some other items you might want, right? People have seen that, right? So you're buying some fertilizer for your garden, and they say, well, you might want this shovel and this watering can, and right? Um, there's plenty of seats. I'll tell you how that came about. There was a software engineer at Amazon who came up with this idea, and he said, geez, wouldn't it be great if we showed him some other things? And his boss said, no, that's a terrible idea. That'll be too distracting. People will get freaked out, and they won't even buy the first thing they were going to buy. So what did the guy do? Did he just give up? No, he released the feature. He released the feature because Amazon has the ability to do multiple different versions of what you think of as the Amazon site and target them to different regions and so forth. So you could release a special version just to Southwest Indiana or something. I don't know exactly at what scale they can break it down, but the engineer just built the feature, released it himself on his own authority, put it out to a small section of the Amazon customers, and then instrumented it to see what kind of sales they were getting. And he let it run for a month or two, and he came back to his boss and said, well, you know, if you put my feature in, sales are up 37%. And his boss went, oh, you're right. I guess we should do this. So this is A/B testing. We try out things, and we're ready to pivot. If the thing we try out isn't working out, well, we head in another direction. Who's working on WasteScript? Who's been doing that? Who's three? Okay. I think we're probably going to move on that project. Initially, what we had with WasteScript was that one of the founders said, well, we want to have a third-party extensions where third parties can build their own icons. And I said, well, that's great. We want visual programming for our systems, so maybe we can do that. And he said, yes, let's do it. We should do that as a project. When September arrived, we went and met with him. Eugenia and I went over to their offices, and he said, oh, we're not ready to do that. We have like these three other things we have to finish first. So I said, all right, well, let's explore the idea of what we can do with some triggers. I don't think there's much further we can push in that direction. Any feedback from you guys? Do you have similar feelings, or is?
I think it's a little limited in terms of what it can do.
Yeah, okay. So this was the feeling I was getting, and so I think what we'll do is we'll pivot. And this is an advantage of being flexible, taking on projects where you just try to make small steps. You try to make a couple small steps, and you see, oh, this project isn't really panning out like I thought it would. So boom, let's drop that and boom, go do something else. And you know, this would have happened, that engineer at Amazon was able to release this to a tiny batch of people. If sales had dropped 37%, he just would have deleted his change and never mentioned it, right? So we want to be able to pivot fast like this. Okay, let's go through some of the next sections. We're trying to make so here's another thing. Okay, the wall plate has been selected, indeed. Okay. Send to left. Let's unplug and plug back in. Power down and power up. And then if we don't come up, then we call media support. Okay. All right, this is another difference. And this is something, so you've been in school and there have been a professor or TA around who's going to help, and that's great. I mean, if I get paid because people need help, right? So I don't certainly appreciate the fact I had mentors who helped me when I was getting going too. But part of becoming your own software engineer who can be given a project and trusted with it is there's a change in attitude. Okay, wall plate. Okay. Projector. Okay, so that's what it is. Hit that. Sometimes, well, often you hear students say, well, I tried the pip install, and for some reason it didn't work, right? Part of the change in attitude is to realize you're the person who has to figure out the reason. You're an engineer, right? So we're the people. So the marketing people and the sales people and the finance people, they come to us and they go, for some reason it didn't work. And we figure out why it didn't work. So this is something you've got to become energetic in tackling your installation problems and your configuration problems. Certainly will help anyone who has knowledge. And even as a pro, you go to other people in your group all the time for help. But they don't want to see that, they want to see that you've given it a good try yourself, figuring out how to configure things. All right, so we're still not displaying, huh? Oh. Someone took this thing out. All right. So certainly get help when you're stuck. However, the other thing is you definitely want to try it yourself. Okay, so we just need to reconfigure the screen. Okay, so we're going to start by looking at Make, because that's your next module, and do a little review of what Makefile is for. Okay, VI Makefile. All right, so Make is a build tool. And there are other build tools for Java. There's Ant and Maven. But Make is a pretty well-developed tool. It's free. It exists on any Linux or Mac system built in, and you can get versions for Windows. So for our purposes, it's a fine tool for controlling the build locally. Then we use Travis CI for the online version of a build tool. Typically, a Makefile starts with a bunch of variables. And the variables exist for the same reason. They're usually constants. They're locations, typically, in a Makefile. But we put them in variables for the same reason we put our constants in a named constant in our C code or Python code, because we don't want to have to change these in multiple spots, right? We're going to reuse these names. One of the things Make does is it can run a shell command, so it can shell out and then capture the output of the shell command into a variable. This is very handy, so if we want to get a list, we want this variable to hold all our Python files. We can shell out and do an ls of the models directory startup py. And this Monk Shuing, this is going to have to include yours. We're going to have to change the make file, so capital is in a different directory. So these things have to evolve sometimes as we change configurations. Web files are the CSS and JS things, so we build up a list of all them through here. Because these are constants, they're in caps. Okay, we're now into the body of the make file. We can do fairly sophisticated things with this shelling. Line 27. Line 27 is LSing PTML files. In our projects where we're building a static website, for instance, when we're documenting the stuff we're doing, we're looking at for New York City, or where we're documenting stuff for SOCNet, or we're documenting Docker, what we want to do is we prefer our documentation in HTML. Why? Everybody has a web browser, right? Not everyone has Microsoft Word, for instance, or a PDF reader. More importantly, yes.
Why not like a .txt file?
Well, we can't put in formatting, right? TXT is okay. So Dolly has arrived. Hello, Dolly. TXT is okay, and if you don't have time to format up an HTML file, TXT is actually the next best thing. Plain text is good because we can run Python scripts on it, for instance. And we do. We run spell checking and link checking on our HTML files. That we could do that on a Microsoft Word file. I have written programs that read Word files, but it's not particularly easy. It's much easier to process plain text, right? So we're going to prefer that. And for static websites, the problem with a static website, if you want a consistent look and feel, you want a menu, you want a logo on every page, you have to code it on every page because there's no back-end processing that's going to include these things, unless you do it yourself on the front end. So this is something you should know about the static websites. We have the root, let's say, the root is the repo name. So SOCNet, right? Let's use SOCNet as our example. So we have SOCNet. And then under that, we should have HTML source. And what we do is, this is filled with files with the extension .ptml. y.ptml. And these get processed by an awk script. It happens. Awk is a text processing language. And produce x.html and y.html. Why? Because we include things like the header and the menu and the CSS files, any JavaScript we're using. And this gives us a chance to process, to do includes ourselves before, on the way to creating the HTML file. So that for instance, I'll show you the difference here. So we could look at this one. So this website has a logo, you know, whether you think it's a good logo or not, the point is that the logo appears on every page, the menu's on every page. We have the same CSS styling. So we go to the code page and the top looks the same. We go to resources, the top is the same, right? Glossary, it's the same. We could have coded that on every single web page, right? But as the site gets bigger, that becomes more and more of a bother. Don't repeat yourself. It applies to your website as well. We want the menu in a single place. We want the logo in a single place. So what we do in order to do that, let's just move over there and have a look. So we have HTML source, right? And let's look at about is a very simple one. Here is the HTML source code that we're going to compile into the HTML. It has these includes in it. And these are HTML comments, so should this fail to process, it's still legal HTML. You'll just be missing things, right? But we have a script that looks for the start of a comment followed by the word include, and then says read this file right into the HTML code wherever that occurs, and we wind up producing. Well, I haven't made so we have a make command. Touch HTML source. When make works on dates, so if it sees that about.ptml is newer than about.html, it will build about.html based on the dates. Sometimes we may have grabbed this off of version control and they're all the same date or something. You might just need to touch the source file, which touch is a Unix command that says give this the current date and time. So I touch it, and now if I make local, about will build, and now I can, all right. Oh, I don't understand. That's interesting. So everything went. So why is this? Oh, right. Okay. Sorry. I'm puzzled because it's because line 14. The files were fine. I was just stumped by it. Looked like the files stopped there, and I couldn't understand that. It's because the next line is so long. It can't display it. So in any case, this is what gets included. So the file is, for one thing, less readable once the includes happen. That's the logo up top. So these things just get pulled in, and now each file has a menu. So we can use make to automatically generate these, and it will just do the ones that were out of date. When I touch them all, it did every one. And we can do things like, this should have spelling and URL checking put in, but right now it is doing tag checking. HTML checker.py checks tag consistency. So let's go back to a make file. So we can do rather sophisticated things. Line 27 is building the HTML files from the PTML files. It lists all the PTMLs, but that's not our target. Our target is that file with HTML substituted for PTML, right? And we may not never have built that yet. The HTML file might not be there. So we can't just say ls the HTML files because maybe they don't exist yet, right? So how do we get a list of the HTML files? We list the PTML files. This is a Unix tool, a stream editor, sed, and it's going to run some substitutes on the list. In particular, it's going to substitute .html for .ptml. Then it's going to pull the directory name out. So we can do fairly sophisticated processing. This took HTML source slash about.ptml and turned it into about.html. Now we are into our targets. Force is a standard name for an empty target when you want to force something to build every time. An empty target will always build. So if you make something depend on force, you'll get that thing building every time. But the general pattern here is we have a target. This is the thing we want to build. So we could, for instance, say make notebooks. So each of the models in the Indra system has a Jupyter notebook that goes with it. The Jupyter notebook was not created by hand. It was created by a script. So that we can, as we change a model, we can or add a new model, we can automatically generate notebooks for each model. This is a typical pattern in Make. Make is not great at handling subdirectories. Usually what you do is you put sub-make files in your subdirectories. And so what we do here, so this is the target. This is what it depends on. It depends on the Python files. And if it needs to be built, we cd into the notebook directory, and then in there run make notebooks. And there's a make file in the notebook directory that will run this. Here's you saw me running make local. This was making local HTML files. Here are the commands that are running. This says from a PTML file, you make an HTML file by doing these things. We run the HTML checker, we run the HTML include, and then we add the newly produced HTML file to Git. Because that's an easy step to forget. It doesn't hurt if we add something a second or third or fourth time to Git. It doesn't make any difference. But it's very easy to forget to do the git add when you first create a file. You need to add it. So we have the target, the source, and what to do to build the target from the source. If anything fails in line 37 through 39, Make will stop building that target. We have a way around that because sometimes we don't care if a command fails. I'll show you that. This is something people have been running, and every project should have something like this to get a developer up and running fast. This installs all the Python packages they need to develop on Indra. We use a utils submodule. This makes sure that that's up to date. These 3 lines can be handled by scripting. What we would need to do would be to edit someone's login script. And that was a little trickier, so for the moment to get this going, I just said, hey, you have to edit this. I didn't have time at the point I was setting this up to write the actual editing, because editing someone's login script, something you don't want to get wrong, right? You screw it up and they might have trouble logging in. Or we had someone who was trying to do this, and they, instead of Python path, they set their path. And they set the path to be Indra, which meant then they said, I can't run ls anymore, right? So because that's a program, it's user bin ls typically, and they had taken it off the path, so Unix could not find the ls command. So it's a fairly serious limitation if you're trying to run in Unix shell and you can't run ls. We deploy the JavaScript somewhat differently than the Python code. The React has its own way of deploying, so we have a target for deploy web app. Tags is something that's useful for VIM, for Vim, so we can build that. Submodules. This is typical. You're going to find that your project should have a target called prod. And what prod does, so these are sub-targets. Prod is first going to do the local target, then it's going to do the tests target, then it's going to do a git commit, a git pull, and a git push. What this does is it runs tests before you commit your code. And this is nice because then you don't have the situation where you've committed your code and Travis goes to run the tests and the build is broken. So we'll talk about that in a moment. I said that there is a way that Make can run a command and have it fail but continue with the build if you put a dash before the command. So someone might run make prod and they've already hand committed everything. And for some reason, Git has decided that if you do a commit and there's nothing to commit, that should be a failure. So the command, so Unix commands in general return 0 when they succeed, return anything non-zero when they fail. For some reason, Git said if there's nothing to commit, we're going to return a non-zero value. To me, that doesn't count as failure, right? It's not like it said, your Git system is configured wrong. I can't do a commit. Just there wasn't anything to commit. If there's nothing to pull, that fails too. So what we do is we ignore failure on line 83 and 84. That dash says, these can fail, we ignore it. This is so sometimes people want to run tests on stuff they've committed already, so we have a different version for that. The test, the target, the source, the dependency is force. This is the empty force target I talked about. This says whenever you run make tests, run all the tests. The tests don't depend on anything. And this is using the word force as a convention here. Force this to run. This has the subdirectory structure again. We have an API server, we have the core library, and we have the models. And they all control how their own tests are run. So to test the project as a whole, we run the tests on the API server, we run the tests on the library, we run the tests on the models. We're going to have to do this on Capital as well. Who's working on JavaScript on the React front end? Okay. We need to get the tests for that in here. We need to have tests for that, and we need to put them here because that code should be tested as well. So that should be a high priority item for you guys. We're going to look at testing a bit today, but the basic principle is a little bit of testing is better than no testing. Thorough testing is better than a little bit, but we want to get going. We want to get something in there that is at least starting to test the React code. We don't have that now. Lint, there's nothing to lint here. The linting is going to be done lower down. There's a general category called lint tools. This comes from a program that was written for C developers in the 70s called Lint. And what it did was clean up C code or help you clean up. It reported problems. And lint is that, little fuzzy stuff that's in your pockets after you do the wash, right? So the idea was this cleaned the lint out of your code. So there are little things that the compiler would not find to be an error, but still were bad programming. So for instance, you had a constant scattered through your code, or the indentation was wrong, or you created a variable but you never used it, or you created a variable and used it without initializing it. The C compiler would allow these things, but they're all considered bad programming practices, risky. So lint tools are the category of tools that try to catch that stuff. We use Flake 8 as our lint tool, and you may, if you are running that on your Python code, you may be kind of surprised at some of the stuff it comes up with. It's all working according to the Python formatting standard, which was a link for you to read in an earlier module. So this is the way the Python community has decided code should be formatted. I don't agree with all of it, but when I write Python, I format my code that way because this is going to help other people read it. It's going to meet their expectations for how the code should be formatted. So we run Flake 8. We want our code always clean passing Flake 8 because when you start to build up lots of problems, then it's a pain in the neck. If you're running it all the time, then you're going to have one line wrong or two lines wrong. So we want that running all the time. So this is the basic structure of a Makefile. We build, this is building our Docker containers for the project. Whenever there's something that you need to build that you're creating as part of the project, you should put a make target in for that thing and capture the commands. We could run this, right? Docker build -t gcala repo docker no cache build arg repo -f. Does anyone really want to memorize this line so that they can type it every time they want to build a Docker container? No. Nah, right? We capture it and put it in a Makefile, and now we say make prod container, make the production container, make the development container. And we may hit Docker today. If we do, I'll show you what the difference between those two containers is. Basically, this one is intended for developers to work in. This one is intended to ship into the cloud and just run. So it doesn't have the development tools. This one is built on requirements.txt and requirements.dev.txt. This one is just built on requirements. This is a distinction that every project should have. All of the things that are outside the repo that are needed to run the project or develop the project should be in requirements files, for Python anyway. And then we'll pip install all that. If you're working with a different language, you figure out how that language, you handle this kind of thing. We reuse the requirements files. They're used for Docker. They're used for Travis, because Travis builds a virtual machine to test our program. And we use them on Python Anywhere when we deploy there to make sure Python Anywhere has all the packages we need. So this is make. So generally speaking, when you want to, Mangshing, no laptops, thanks. Generally speaking, when you're ready to release, your project should have a target called prod, and you should run make prod. Why? Because it'll run tests for you, and if there's problems, you'll find them locally. So this runs subtests, and we find that there is indeed problems, right? So what we have is a bunch of Flake 8 problems on this file. So I thought we would fix them up right now, and we can do it in just a minute. Can someone quickly note these line numbers? If we had a bigger screen, I'd bring up side-by-side windows. So we have 23, 24, 51, 52, 54, 55, 58, 59, 60, and 61. So let's just zip through these. So what do we have, 23?
24, 59.
Okay, so Python formatting standard says two spaces before a comment and always a space after the comment sign itself. This is more readable. When I see pound list, it looks like it's some new word that has punctuation tacked on the front. 24, what's next? 51. Okay, this is an indentation problem. They're very fussy about this. They want this indented like this. This should be right under the thing it matches up with. So it's a minor thing, but this is part of the coding standard, so we should meet it. Okay, this line is now too long, so we can do the same thing here and indent that. So we have a 79 character limit on line length. This one, you may think, oh, geez, I've got a big screen. Why do I want to limit? Can't I write 130 character lines? People project code, and these projectors typically have much less resolution. People print code on paper, and the paper typically will have a problem with lines that are too long. A lot of people run multiple windows and set them to, typical setting is to set them 80 characters wide and run like 5 terminal windows, and your lines will wrap on their terminals. And then ultimately, if you think of how, if you look at the New York Times, right? It's got a wide page, right? Have you ever seen an article run all the way across the page? Right? They run it in columns. The reason is that newspaper publishers figured out long ago that we're better at reading, scanning a not so wide column and going down it than we are going across very long, very wide columns. So it actually is tough to read when the line extends. So the 79 character limit might seem a little arbitrary, but it's actually sensible, I say. And now these lines need, so these all have to be indented to there. Oops. Okay, so now what failed was running Flake 8 on capital. Okay, now it passes. So I can just run it by hand, right? Rather than kick off make prod again, which will test a whole bunch of other stuff before I get to this to see if it fails. Because I might have missed fixing something, right? So this is fixed now. So now that I know that it's fixed, I can run make prod. And you can figure out, you can look in the make file and see what commands it's running. And you can run them yourself to see if things are fixed up. Okay. Commit messages. Often they're good. Sometimes we get, I made a change. Right? Well, yes, if you're going to be pushing new code, presumably it's because you made a change, right? There's not really any other reason, or fixed something. I look at the commit messages and try to see what people are working on, if they're stuck on something, if they have the right idea of where the project should be heading. So write your commit message as if you're sending me a note about what work you just did. So this fix Flake 8 problems in capital.py, I think, it's not length, right? It's not that you have to write a book when you do a commit message. Just let everyone else know what you're up to. And this is important. Programming is a social activity for almost everyone who does it. There are occasional instances of the genius programmer who works by himself in a room and releases to the world. Donald Knuth, right, wrote Tech because he was unhappy with the formatting of his own books. So he wrote a whole book formatting system that could do equations and so forth, and did it pretty much by himself, I think. But this is only really rare, right? For the most part, people wind up working in groups, and it's crucial that you communicate to the other people in your group what you're up to. Because if something's broken, we want to see, well, who's pushed stuff lately? What did they push? Which of these commits might have broken this thing? So if you give people a good idea of what you've been working on, then they have a much better chance of knowing, okay, should I be looking at this commit or this commit or this commit to see where this problem came from? Okay, so we do our commit message. And you can set what editor, you can do -m at the command line when you're committing on your own, but you can set what editor is going to be used for your commit messages. I, in fact, just had to reset it. On Unix boxes, Linux, you're going to have .bashrc as your login script. Mac, it's going to be .bash_profile. I just had to set, it was using Nano or something as my editor, so I just set these. So, but if you prefer Nano or Sublime or Atom, you can set it. So you don't have to use Vim. Vim is a little tricky to get going with.
I've not been using Vim since 2012.
Well, that's excellent. I have you beat, though. I've been using it a little longer than that, but that's very good.
Yeah.
But it is a little tough to get going with,
I know.
right? So, one of the things is people get stuck. They don't even know how to leave, right? They get into Vim and they go, what do I do now? I'm stuck. My screen has been taking over for Vim. I can't get out. Now, an idea that we got from Toyota, we being agile and lean and DevOps, is that we watch for the production line being broken. And sign in with GitHub. Okay. These CI/CD tools are built to help us watch that we can build production at any point. So we always want to be able to deploy our software. Why? Well, as opposed to the waterfall model, right, where you came to someone and you said, this calculation, your programmers, this calculation is not working. It's giving us the wrong number for the price of this option that, the traders are looking at. Can you fix that? And they'd say, yes, the next release is in a year and 2 months. We'll fix it then. That's a long time to wait for something broken to be fixed, right? What we want to be able to do is respond right away. If the customer says, I went to your shopping site and I couldn't buy anything. Well, that's terrible, right? They can't buy our product. We're not getting revenue. We want to fix that and put it out immediately. If the software is not in a deployable state, we can't deploy that fix, right? If our biggest customer says, hey, I need this screen changed from green to vermilion tomorrow. If the software is not in a deployable state, we can't do that for them. So we want to keep things deployable all the time. We say the build is working or the build is broken. And Travis is a tool that checks that for us. It checks that. It builds a virtual machine. It installs all our packages, so it does a bunch of installs. Then it runs our tests. Should the test pass, Travis will then, after success, it will do a deploy. Let's see if we can make this a little bigger. Okay, so it's actually deploying the new code to Python Anywhere. So it uses SSH key to log into Python Anywhere. And then it updates. So Python Anywhere has another copy of the repo, right? So Git is a distributed repository system. GitHub has a copy. Your machine has a copy. Python Anywhere has a copy. So to get the new code there, we just do a pull. So same thing we do locally or to get the new code. We do a pull, and then we reboot the server. Capital. Oh, then we install all the Python packages, and then, so this uses requirements and requirements dev, and then going to reboot the server, reloading indrasnet.pythonanywhere.com via API. So it rebooted the server, picking up the new code. And then last, we make the Docker containers and push them to Docker Hub. This is all controlled by a file called .travis.yaml. So some important principles here. I'm about to edit a text file that controls how Travis works. First of all, it's plain text. It's very simple code. It's code we check in and put under version control. So the deployment itself is a scripted, repeatable entity that is itself under version control. So it's not controlled by clicking, checking boxes in a window, or pushing a button that says go or anything like that. We want, whenever possible, to script everything, automate as much as we can. This is a boring, repetitive process. We want the machines to do this, and we want them to do it in a way that's transparent to us, where we can examine the way the machine is doing it. We could, in many cases, actually, we should be able to automate the creation of this file itself. Because it's plain text and it has regularities, a lot of it can be just stamped out as template. So another thing we want to do constantly during our work is ask, can we push things up to the next level of automation and abstraction? Okay, we've built a Django website, and that's automated the process of putting up courses. Can we automate the process of putting out a Django website? And I'm going to show you a script we've got that is doing this for static GitHub sites, so you can see this idea at work. We should be able to automate the creation of the Travis YAML. For instance, what we're going to install is always going to be this file, right? For any Python project, at least. So this is a YAML file. It tells us we need Python version 3.6. We're going to have the Docker service. We get our SSH key. We install this. We set some environment variables. This is the main script that's run. If this succeeds, then we deploy the product. And this is a key thing that this lets us do. If any of these tests fail, the product isn't deployed, because this is in a section called After Success, right? And then we get notification on Slack. And if you look, there's a channel called Travis in many of the projects. If there's not in yours, you should have one. And that'll get a notice, hey, this build succeeded, or the build failed. And we want to watch for that. This was straight from Toyota. Toyota had the production line, and they want to have no waste, no defects there. So one of the things they were striving to do is produce defect-free cars, and they wanted to do this by making every place in the production line defect-free. And therefore, they set up a system. Typically, they would have something that looked as kind of like a traffic light. They would have green and red lights. And as long as the production line, everything was going fine, the light would be green. As soon as any workstation in the production line had any kind of stoppage or any kind of problem, the light would turn red. And the production line was broken. at the point the production line was broken, it was the number one responsibility of every person on the entire production line to fix the spot it was broken, not to keep making their product, because then you'd get inventory piling up. So if you kept making steering wheels when the person who was attaching them couldn't attach them, what you'd build up steering wheel inventory, and Toyota said, this is a form of waste. We want to make sure the steering wheels fit in the steering wheel assembly, stop making them, fix the place that's broken, then go back. And for us, when the build is broken, it's important not to push new work, right? We need to fix the thing that's broken and only then start pushing again. If we have stuff that's broken and we're pushing new work on top of it, that new work might be incompatible with the fix, right? So whatever we have to do to fix it, we should get the fix in first and only then start putting out new work so that we know. Also, we don't know, is the new work broken because the build was already broken, right? So we already had the build go red. You see in Travis, we can get our build history and the build is green here. That means it worked. But we can look at the build history and we will see occasional. Okay, so we have a failure an hour ago, all right? So we have to look into this and see what happened. Well, and we can look here. Well, it's probably the thing I just fixed. Yeah. So it's the flakegate problems that were just fixed. But this build shouldn't have been started because the previous build failed, first of all. And second of all, when it failed, the person who did the build should have jumped right on this and tried to see what's going wrong. How do I fix it? And it doesn't matter if it's you created the problem or not. The responsibility of everyone when we have a failing build, the first responsibility is, Dennis, when a build is failing, fix it, right? Fix it. And everyone, all hands on board, right? It's everyone's responsibility. Fix the failing build. This summer, it was everyone was working in one area, so it was actually kind of more like a realistic environment, because as soon as the build was broken, everyone knew, and everyone would go, what happened? We got to get this done. So we got to really apply this principle in an in-person way. Okay. Let's look at next tests. So, automated testing is vital to being able to move fast. If you're trying to move fast and you don't have a decent automated test suite, you're going to wind up putting bad code into production frequently. I break things all the time, right? We should have the expectation. We're human beings. We slip up. We make mistakes. What we want is we want to make it so that the machine catches this stuff for us to the greatest extent possible, so that if we pass the tests, we can feel pretty confident that our code is okay and not going to break anything. It's not always the case. The tests aren't perfect, right? Sometimes we pass every test and we put the code in production and things break. And this happens, and then we just want to be able to roll back quickly. We have the code under version control, so we can cut back to the previous version or fix it quickly if we know what the problem is. Sometimes the fix itself is very easy, and we can deploy that fix fast. But if we're going to be deploying a fix to something that passed the tests, it's out in production, and it's still a bug, we want to fix that on top of a build that's already working. If the build is broken for some other reason, now production is broken, we can't put out our fix because the build isn't working, right? So something else broke the build. This is part of why we treat a broken build as an urgent matter. We fix it as soon as we can. And you should get in the habit of checking Travis. There's travisci.org and travisci.com. Depending on your project, .com is where everything is moving to. Indra is stuck on .org because when we set it up, free projects had to go on .org, and .com was for paid projects. And they have not built the migration tool to move from org to com yet. So we're stuck on .org for Indra. But most of the projects should be on travisci.com. So you should get used to the fact when you push to production, you watch the build and look and make sure that it's still green after it finishes. If you don't have this set up for your project yet, it should be. So even if the project, if like it's SOCNet and we're in the early days of documenting stuff, well, there's really nothing to test yet. So only at the point we start coding do we actually need to worry about setting up Travis for something like that. So some of the projects are in very early stage where you're just exploring other packages or something. And it's a little bit of overkill. What are you going to test? You know, we could run the HTML checker on any HTML files we make, but it's not terribly important at the very early stage like that to have Travis set up. But if you're coding, you should have Travis working. So for instance, the scheduler, you should make sure that you've got good tests in Travis. We should get testing for that as soon as possible. I don't think any tests were written over the summer. So before we look at the technical details, the general strategy we should follow is that the test should never be significantly behind the code. This happens, it happened with the scheduler over the summer. The person working on it worked largely outside of campus, so I had very little control over how the progress went on that project. There is a discipline called test-driven development, and you can look at Bob Martin talking about this online. Bob Martin is all over YouTube with dozens and dozens and dozens of videos. He's usually worth watching, worth listening to. He's a very experienced developer, but he talks about test-driven development, and he has an extreme version where you don't write any code until you've written a test that fails for the code you haven't written yet. So let's say you're going to create a new class called employee. Well, the first thing you do is write a piece of test code that constructs an employee. And of course, immediately that fails because you haven't written any code to construct an employee. And then he says what you do is you go write the smallest amount of code possible to make the test pass. So you write a constructor for employee. And now the test passes, and now you write the smallest amount of tests that will fail again, so you check the employee name because your constructor was empty, right? Because that passed the test, to have an empty constructor. And of course, there's no name because the constructor was empty, the test fails. Now you go back to your code and write the code that puts the name in when you construct an employee. And he says, this sounds incredibly tedious and like you're never going to get anywhere. Oh my gosh, how could you go back and forth this much? He said, but if you did this, every single person developing would be within seconds of having working code all the time, because you're never doing anything except writing the next small little batch of code that will make your test pass. So there's a few seconds in which the test is failing before you've gone back and added employee name, and then it passes. So you're always within a minute or two of having clean working code that passes all the tests. I sometimes do this. I sometimes do test-driven development. But at the very least, we should make sure our tests keep pace with our development, which means every time you write a new function, you should write a test for it. The tests, at first, they might be rather simple. So let's look at writing a test. And I'm going to show you this for Python. Every language has similar test tools, every mature language. That's in serious use for development has tools like this. So, in general, you should have a directory called tests in the directory your code is in. And in there, you should have files called test underscore and the name of the module being tested. Let's look at, let's run MakeTest. So we have a target called tests, and we'll look at several parts of our, okay. MakeTest runs Flake 8. It also runs all the tests. It will stop if any of them fail. It's hard to scroll around this. Okay. We use a couple of tools. We're using unit test as our main testing tool. That's standard. It comes with Python. We use nose, which is a test runner. It's not the testing tool itself. What it does is it finds and runs the tests. So it's going to do this based on name. It's going to search for a folder called test or tests, and in there it's going to search for files starting with test underscore and run them all. And nose works hand in hand with a tool called coverage. Coverage gets us an estimate of how much of the code has been tested. Someone said, how does it do that? And my response is, well, it's open source. Go have a look. But what it's going to do, it's going to compare the test and the source code, and using some intelligence and parsing capabilities and so forth, try to determine how much of the source code is being tested by the tests. I'm sure it doesn't work perfectly. It works well enough that we see as we write more tests, the coverage number goes up. So it gives us a pretty good idea of how thoroughly things are being tested. We want to see numbers up around 90%, 88, 85, that's not so bad. 55, 58%, those aren't great. So let's look at that and see if we can write a test for one of those files. We have, whoops, I didn't mean to do that. I ran the tests again accidentally. Okay, so the person working on this humorously named it Drunks. It's a famous example of a agent-based models are often used to study social phenomena, in particular social phenomena where we can say what we have at the individual level, what behaviors we're going to have, but where it can be rather difficult to say what the outcome of those individual behaviors is going to be. So, for instance, this model, which, as I said, he called it Drunks, is a model of a bar, and apparently it was a bar where the guys who made the model actually used to go. It was a nice bar, but it was small, right? And so what happened was people loved going there until it was too crowded. And once it was too crowded, they didn't want to go. So we have a kind of a paradoxical situation where if no one was there, everyone would want to go. But if everyone went, no one would want to go. So how many people wind up there? Well, you know, you might say no one, you might say everyone, right? But maybe we get is there some equilibrium in between? Well, we can use agent-based models to test this kind of situation. We have a lot of these things, the Holmes-Moriarty problem. Anyone a Sherlock Holmes fan? You know the Holmes-Moriarty problem? Yes? Do you want to describe it, or should I? Okay, I'll do it. So Sherlock Holmes' main enemy is Professor Moriarty, which I thought that was kind of vicious for Conan Doyle to make a professor the really evil guy. Didn't think that was nice of him at all. But Professor Moriarty, yeah, maybe he was spot on, huh?
Well, professors are a little bit evil.
Yeah, well, yeah. They can be a little bit hard grading too, you know. especially to the people who refer to them as evil. Then that can be an immediate 10% drop. Of course, I'm joking with you, Peter. You're free to call me evil as often as you want. Holmes and Watson are getting on a train, and Moriarty and his men are going to kill Holmes. They've decided he's too much of a bother. It's time to murder him. And they get on the train in northern France, and they buy tickets for Geneva, Switzerland. And Watson says, oh, well, we're going to go to Geneva. And Holmes says, well, Moriarty's men were watching. They saw us buy the tickets for Geneva. And Watson says, so we should ride the train just part way and hop off early. And Holmes says, yes, but Moriarty's very smart. And he'll know that we're going to get that we know that the men saw us buy tickets for Geneva, and that therefore we're going to think we should hop off early. And Watson says, oh, so he's going to look for us early. So we should ride all the way to Geneva. And Holmes says, but Moriarty's very, very smart. And he's going to know that we figured out that he watched us buy tickets for Geneva, and that he's going to think we are going to jump off early, so that therefore we're going to ride all the way to Geneva. And this just keeps going. There's no easy way out of this circle, right? So in social situations, we can get a lot of these kind of things where we get a paradox, and we can use an agent-based model to explore it and see if there's any way out of the paradox. The people know Yogi Berra. He was a catcher for the Yankees and a manager, and he is famous for saying paradoxical things. He said a lot of them, so it's not clear whether he was being intentionally paradoxical or he accidentally, but they asked him about a restaurant, and he said, that place is so busy that nobody goes there anymore. So this is the kind of thing we have in the bar situation. So let's see if we can write a test for it. So we're going to test by looking at the files. So we have get decision. Okay, so we're going to make a random decision. I don't know why. Okay, we're getting a random decision. So this code looks, okay, this looks incorrect, because this is floating point division. So it looks to me like we're going to get not a random integer, but a random float between 0 and 1, which we could have gotten by calling random itself. We didn't need to call randint. So whether the code is correct, so let's hedge our bets. First of all, so here's something why names are important. Random integer, right? You're going to be led to believe that this is probably an integer, given the name, right? But when I look at the code, if we get a number between 1 and 100 and divide it by 100, we're going to have a number between 0.01 and 1. I don't know if we wanted 0. So this looks to me like it's not an integer at all, right? So that name is kind of deceptive. So let's just change it to this for the moment, okay? And then when we write the test, okay, so if the random number is less than the agent's motivation, they're going to go to the bar. And if it's greater, they're not going to go. So let's see if we have a test for that. We do. But how, why? Oh, is it a Boolean? Okay, that is a test. Let me show you the structure of one of these files. We don't run flake8 on these, but we probably should. Here's a flake8 error. That little black strip there means that there's white spaces on an empty line. Why does that matter? This matters because it can create spurious versions of a file in Git. Git will look for any differences, and if you commit and there's anything changed, it'll say, okay, here's a new version. Some editors will remove these spaces. So if you type them in and someone edits it with an editor that trims them out, that's a new version, even if they haven't changed a single line. So this is a violation of the PEP8 coding standards, and there's a reason for that. It's because it creates spurious new versions of source code. So we want to delete that. So let's discuss the structure of the test file. Okay, unit test is the standard Python testing tool. Pretty much every test you're going to write, you're going to import the same two things. There are other things in there. I've never had to import them. You might find you have to at some point. But test case is the class that we're going to subclass for our tests, and main is what's going to run the test for this file. So we subclass test case, and we get drunk's test case. This should be named after the file. There's two special functions that unit tests allows us: setup and teardown. What these do, setup, this class has a bunch of methods. Any method beginning with test underscore will be run as a test. Before it runs any test, before it runs every test, it'll first see if there's a setup function. If there is, it will run setup. Then it will run a test, then it will run teardown. Then it will find the next test, run setup, run the test, run teardown. Why do we want this? What this does is it allows us to get our class, our model, our data set up in a particular way we want, and then because we tear it down and set it up again and again, it means that the data is clean for every individual test. So the tests are not going to impact each other. The data so a test might, for instance, change an employee record, and a new test comes along and wants to do something with the employee record and expects it to be in its initial state. So test A could make test B break. By running setup and teardown before and after every test, we make sure each test has new clean data whenever we need it. We don't need those. And if your tests don't need them, don't worry about it. But it can be handy. It can help us get. So for instance, in this model, we want to bar the drinkers and the non-drinkers. And that code would have to be repeated probably, test after test, to set that up. And after we've run a test, we want that cleaned up so that the next test gets fresh instances of those things. So having set up and tear down allows us to do that in a clean, uniform way. We don't need to repeat that code, and we know it's going to be run before every test, set up, and after teardown. The basic structure of a test is it's going to execute some part of your code, and this is called unit testing. What we're doing is we're exercising individual functions. It's a nice reason to write small functions, besides the fact they're clear, they're more understandable. Also, they're easier to test. We can completely test a function if it's 3 or 4 lines. It's usually easy to write a simple test for it. So this just asserts that what we get back is a Boolean. But we could do a little better than that, I think. What if we did this? I'm considering whether we could pass an optional random number in and then use that to see if we got true or false. But someone could flip the sense. They could say if the random number is greater than their motivation, they should go out. So I don't know if that's a wise idea. I'm going to look for something else to write a test for. Discourage. So we don't have a test for discourage. All right. So we always get self as a parameter. By the way, we'll just poke ahead and have a look at main. Main is very simple, right? We want 2 spaces there. This just kicks off the main from the unit test module, which is going to run through all the test cases. So let's look at what discourage does. So, okay. These things are extremely annoying to maintenance programmers who come, anyone coming to the code after you. While random drunk not in scene, okay, so there was some intention to do something with random drunks, but it's not in the code. So why? And we append to scene here. But that's commented out as well. So is this important code that ought to be running? If it's not code that ought to be running, why is it sitting around in the file? Right? If it is supposed to be running, why is it commented out? This is something to not do. It's okay for a few minutes while you're debugging something. It's okay while you're trying an alternative. But before you push your code, you should clean anything like this out. A print statement, we actually can handle this better. We make a debug variable and print it if debug is on. But the prints we understand, those were debugging statements, right? It's better to put them So let me show you how to handle that. We have, nope. Okay. Put this up top. This looks kind of long. We can quickly test. Ooh, just right at the edge. I'm going to break it up just because the next thing we add is going to make the line too long. So just before we hit it. So now, first of all, it's clear why these are here. They're not just things that are commented out and mysterious, and we can turn them on or off. We just turn debug to true, and these prints will come out. So this is a nicer way to handle that. But it's understandable what they were. They were debugging statements. They were commented out when they weren't needed, but left in because maybe at some point we want them back. However, these other lines, I don't know what they are and why they're there. So the function returns 0 all the time. And how is it called? We have to end off because I have to go give another talk anyway. Okay, I'm going to write what is not a good test just because we're out of time. And it's going to drunks.discourage. Does it have a parameter? Unwanted. Uh-oh. Let's see what this is. Extras. Okay, so it's a number. It's a number, okay. Back 5. We'll discourage 5. And I'm going to, right now this is returning, so we'll change it. So he ignores the return. Let's use the return, okay? Again, we have this commented out, discouraged equals 0. So each time I discourage someone, I'm going to plus equals 1. And now I'm going to return the number I discouraged. So what we did was we took a function that was very difficult to test because it wasn't really giving anything back to us meaningful. And we changed it so that we're getting something back. This actually should probably be a for loop. Instead of a while loop, but this will work for the moment, so we can test it like this. Self.assert equal discouraged. I don't know how many agents he set up in his test case. So I'm going to change this to 1. Because we should be able to discourage at least 1 agent. Okay. Okay, we have, it can be handy in your make file to make targets for the individual models, because right now I don't want to run the whole suite of tests. I'm going to make prod, but I don't want to right now. Nose test is going to find the tests, no capture, says let standard outcome through to our screen. By default, nose test will capture it. So let's just try make test drunks. So again, we don't have to discourage, and it passed. Okay, so I just, now if we say make tests, drunks moved from, drunks was 58%, it's 67%. So I've upped my coverage, I've made a test for the discourage function, I've made sure that's at least running sanely. It's not a great test yet, but some test is better than no test. If I tried to discourage some people and no one got discouraged, well, there's something wrong. So I made sure that at least I discouraged someone, right?